Hello, Middle 3. Today we will explain Lesson 3 in Unit 2, Radioactivity and the Nuclear Energy. Number 1, we will talk about the atom. The composition of the atom is responsible for the physical and chemical properties of the element. The mass of the atom is concentrated in the nucleus. Why? Because the mass of electrons is negligible compared with the mass of protons and the neutrons in the nucleus. There are two forces inside the atom. Number 1, repulsion force. Repulsion force is electromagnetic force between positively charged protons. Number 2, nuclear force. Nuclear force is a strong attraction force between protons and the neutrons when they come very close together. This force holds protons and the neutrons together inside the nucleus. So, the nuclear force is much stronger than the repulsion force. Nuclear energy. Nuclear energy is the energy stored inside the nucleus. Nuclear binding forces, they are the forces that are necessary to bind the nucleus components together and overcome the repulsion forces that are present between the positively charged protons and each other. Radioactivity phenomenon. Radioactivity was discovered by the French scientist Henri Becquerel in 1896. He discovered the emission of an unseen ray from uranium element which penetrates solid objects. Radioactive elements. They are elements whose atoms, nuclei, contain a number of neutrons more than the number required for its stability. For example, radium, uranium, cesium, selenium, zirconium, rubidium. Isotopes, they are atoms of the same element with different number of neutrons and with the same number of protons. Radioactivity phenomenon. It is a spontaneous decay on the nuclei of radioactive elements that are present in nature in an attempt to achieve a more stable composition. Radioactive elements emit invisible radiation as alpha particles, beta particles, and gamma radiations automatically. Why? To get rid of the excess energy to achieve a more stable composition. Types of radioactivity. Number 1, natural radioactivity. It is the radiation produced from the natural radioactivity elements present in nature. For example, rubidium, selenium, zirconium. Number 2, artificial radioactivity. It is radiation or nuclear energy that is released from nuclear reactions. Nuclear reactions can be controlled, like which done in nuclear reactors and are used in safe uses. Number 2, nuclear reactions cannot be controlled, like which done in nuclear bombs and are used in military uses. Safe uses of nuclear energy. Number 1, in medical field. Treat and diagnose disease as cancer. Number 2, in agricultural field. To eliminate pests and improve some plants. Number 3, in industrial field. to convert sand to silicon sheets, which is used in manufacturing of computer processors of electric appliances, to discover defects in the manufactured products. Number 4, electrical generation field. Nuclear energy is used to heat water to produce steam, which is used to operate turbines to generate electricity. Number 5 is space exploration field. Radioactive materials are used as a nuclear fuel for rockets that fly in space. Number 6, drilling field. Drilling for petroleum and underground water. History. Dr. Ali Mustafa Musharrafa is an Egyptian scientist who was described by Einstein. He has great theories in the fields of atom and radiation. Basics of manufacturing the atomic bomb were based on his theories. He gave his objection to this matter and called for the necessity of exploiting the atom and radiation for the benefit of humanity. Radiation pollution. It is the increase of amount of radiation in the environment. Its sources. Number 1, natural radiation sources. Number 2, artificial radiation sources. Natural radiation sources, natural radioactive materials found on Earth's surface, and cosmic radiation from outer space. In artificial radiation sources, due to the explosion of nuclear bombs that some countries do an experiments from time to time, and the nuclear reactors. Example for radiation pollution. The explosion occurred in the Russian reactor at Chernobyl. In 26th of April 1986, an explosion occurred in the Russian reactor at Chernobyl as a result of an error in operation. This led to the melting of the reactor core, which led to nuclear explosion and the release of many radioactive elements. These elements formed an atomic cloud. This polluted cloud was carried by the wind to many countries in Europe. When rain fell in May, it carried radioactive elements to the Earth's surface. The plants and soil were polluted by the fallen radioactive isotopes. Cows and sheep ate these plants. Their milk products and meat were affected by radiation. The elements found in polluted food after the Chernobyl accident were iodine and cesium isotopes. They are elements produced from the decay of nuclear fuel, uranium-235, when absorbing the neutrons. So, give reason, the radiation pollution may be occurred in areas at which a nuclear explosion is not occurred, because the radiation pollution may be transferred by the dry falling through wind or by falling of rains to the Earth's surface. Radiation effect on the human body. Effect on the exposure to a large dose of radiation for a short time. Number 1, bone marrow. Bone marrow is responsible for the formation of red blood cells. It is the first which is affected by radiation. Decrease in number of red blood cells led to feeling of being sick, sore throat, vertigo, and diarrhea. Number 2, spleen. digestive system, and central nervous system. Effect of the exposure to a small dose of radiation for a long time, months or years. Number 1, physical effects. Changes that appear on a living organism as a result of exposure to radiation like skin cancer. Number 2, genetic effects. Changes in the sex chromosome compositions found in the cell which result in abnormal birth. Number 3, cellular effects. Changes in the cell's composition which led to destroying the cells. If the chemical composition of the hemoglobin changes, it becomes incapable of measuring radiation. Measuring unit for nuclear radiation absorption is the sievert. The maximum safe dose for nuclear radiation for radiologists, people works at nuclear radiation field, is 20 millisievert per year. But for public is 1 millisievert per year, when 1 sievert equal 1000 millisieverts. Means of protection from radiation pollution. Workers with radioactive elements in labs and hospitals should wear radiation protective gloves, clothes, and masks. Follow the following precautions while dealing with radioactive wastes. Number 1, radioactive waste should be away from underground water paths to prevent its pollution. Number 2, the area chosen for storing radioactive wastes should be stable, not exposed to earthquakes and volcanoes, and away from animals that live in caves. Nuclear wastes of weak and medium radiation are surrounded by cement layer or rocks, and strong nuclear wastes buried deeply in the ground. Issue laws for nuclear plants to cool the hot water before throwing it in the seas and lakes. So give reason, some plants make artificial lakes for themselves to throw their nuclear waste in it. Okay, thank you.